Bismillahirrahmanirrahim. Assalamu alaikum dear students. It's your physics class, and in today's class inshallah we will solve our examples of unit number 3. Now let's start from example number 3.1. The statement of 3.1 is: what force is required to produce an acceleration of 6.00 meter per second square in a cricket ball of mass mc 0.16 kilogram and metal ball for women shot put game with mass ms equals to 4 kilogram. Now here two masses are given to you, and the acceleration is also given to you, and we have to find the force on cricket ball and the force on metal ball. Now our given data will be mass of cricket ball mc, m for mass and c for cricket, it is equals to 0.16 kilogram. Mass of metal ball, it is represented by ms, equals to 4 kilogram. Acceleration represented by a, and it is 6 meter per second square. Now the required data will be force on cricket ball fc equals to question mark, and force on metal ball represented by fs equals to question mark. Our formula will be F equals to ma by Newton's second law. Now in solution, we first find the force on the cricket ball, that is represented by Fc. Now we know that F equals to ma, so Fc equals to mca. By putting the values, we get mc equals to 0.16 kilogram and a equals to 6.00 meter per second square. So by multiplying these two values, we get 0.96 kilogram meter per second square, and this kilogram meter per second square, it is equals to Newton. Now our Fc equals to 0.96 Newton. Now in the second part, we will find the force on the metal ball, that is represented by Fs. Now our formula will be Fs equals to msa by Newton's second law. By putting the values, we get Fs equals to ms is equals to 4.00 kilogram and a equals to 6.00 meter per second square. So by multiplying these two values, we get 24 kilogram meter per second square, and it is equals to 24 Newton. So our result will be force on cricket ball Fc equals to 0.96 Newton, and the force on metal ball Fs equals to 24 Newton. Now in this way, we have to find the two forces. Let's start example number 3.2. In example 3.2, the mass of a girl is 60 kilogram. How much will she weigh on the earth in part A, and then in part B on the moon? Take acceleration due to gravity for the earth as GE equals to 9.8 meter per second square, and for the moon as GM equals to 1.6 meter per second square. Here in this statement, only mass is given to us, and we have to find the two weight on earth and weight on moon. The two accelerations are also given to us. The acceleration due to gravity on earth, that is ge. G is acceleration, represent the acceleration, and E for earth, and gm, it is the gravitational acceleration of the moon. Now our given data will be mass of the girl, that is represented by m equals to 60 kilogram. Acceleration due to gravity on earth, it is also given to us, represented by ge equals to 9.8 meter per second square. Acceleration due to gravity on moon, represented by gm equals to 1.6 meter per second square, and the required data is weight on earth equals, represented by we equals to question mark, and weight on moon also represented by wm equals to question mark. Now we know that the formula of weight equals to w equals to mg. Now in the solution, we first find the weight of the girl on earth. So for this, we have we equals to mge. By putting the values, we get m equals to 60 kilogram and ge equals to 9.8 meter per second square. By multiplying these two values, we get 588 kilogram meter per second square, and it is equals to Newton. Now the weight of the girl on the moon, it is formula wm equals to mgm. By putting the values, we get m equals to 60 kilogram and gm equals to 1.6 meter per second square. So by multiplying these two values, we get 96 kilogram meter per second square. and this kilogram meter per second square equals to Newton. So we get the result: weight on earth WE equals to 588 Newton, and the weight on moon, that is represented by WM, it is equals to 96 Newton. Let's 3.3. In example number 3.3, an iron shot of mass 6 gram is fired with an air gun. If the velocity of the shot is 62 meter per second, what is the magnitude of momentum? Now in this statement, the mass is given to us, it is in gram, and the velocity is given to us, that is 62 meter per second, and we have to find the momentum. Now our given data will be mass represented by m, it is equal to 6 gram. Now we convert this gram into standard unit, that is the kilogram, and for converting into kilogram we have the rough work: 1 gram equals to 1 by 1000 kilogram, so 6 divided by 1000 kilogram, and when we divide 6 by 1000 we get 0.006 kilogram. Now it is our mass. Velocity equals to 62 meter per second. Our required data: momentum represented by P equals to question mark. The formula of momentum equals to P equals to mv, because momentum is the product of mass and velocity. By putting the values in the solution, we get m equals to 0.006 kilogram and v equals to 62 meter per second. So by multiplying these two values, we get 0.372 kilogram meter per second, which is equals to Newton second. Now our result will be momentum P equals to 0.372 Newton second. Let's 3.4. To improve the safety of motorists, modern cars are built so the front end crumples upon impact. A 1200 kilogram car is traveling at a constant velocity of 15.0 meter per second east. It hits an immovable wall and comes to a complete stop in 0.25 seconds. Now in part A, what is the average net force exerted on the car, and in part B, what would be the average net force exerted on the car if it had a rigid bumper and frame that stopped the car in 0.040 seconds. Now in this example we have the given data, that is mass m equals to 1200 kilogram. In the initial velocity VI equals to 15 meter per second, which is given in the question, towards east. The final velocity Vf equals to 0 meter per second. The time interval deforming, delta t equals to 0.25 second, and the time interval rigid, delta t equals to 0.040 second. Now here the required data is average net force deforming F equals to question mark and average net force rigid F equals to question mark. Now here we find the two forces. Now the formula of force equals to F by second law of Newton, we get F equals to ma. We also know that A equals to Vf minus Vi by T by first equation. So A equals to Vf minus Vi divided by T. And in the solution, when we put the values, first we find average net force deforming, and the formula is F equals to m into Vf minus Vi divided by delta T. Putting the values, m equals to 1200 kilogram, Vf equals to 0 meter per second, Vi equals to 15 meter per second, and in the denominator the time is 0.25 second. When we subtract 0 minus 15, we get minus 15 divided by 0.25 second. 1200 multiplied by 15 equals to 18,000, and plus minus minus 18,000 divided by 0.25, we get minus 72,000 kilogram meter per second square, and kilogram meter per second square equals to Newton. Now it is towards east. when we convert its when we write its opposite direction, so the minus sign will be ignored. So it is 72,000 Newton towards west. Now in part B, average net force that is rigid, F equals to M, same formula is applied, Vf minus Vi divided by delta T. By putting the values, F equals to M आपके पास 1200 किलोग्राम and Vf 0 meter per second, Vi 15.0 meter per second, and the time will be changed, that is 0.04 second. Now by subtracting the two values in the numerator, we get 15.0, and when we multiply 1200 with 15.0, we have 18,000 plus minus minus, and when we divide 18,000 by 0.04, we get 450,000 kilogram meter per second square with the sign of minus. Now this minus sign is in the east direction. When we change the direction in the opposite, that is west, so our minus sign will be ignored. So we have F equals to 450,000 Newton towards west. Now our result will be average net force deforming F equals to 72,000 Newton towards west, and average net force rigid F equals to 450,000 Newton towards west. So these were our 4 examples. I hope that these all are clear to you. So till the next class, Allah Hafiz, take care.